Today we are going to look at L'Hopital's rule, which is another way to evaluate a limit, especially if it is indeterminate, meaning that when we evaluate the limit with direct substitution, we either get 0 over 0 or infinity over infinity. L'Hopital's rule allows us to take the derivative of both the numerator and denominator and then evaluate with direct substitution. To be able to do this, you need to first show that the limit of both the numerator and the denominator separately are both equal to either 0 or infinity. If you do not show this, you will not receive full credit on the AP exam. And then you have to state that you are using L'Hopital's rule, show the derivative of numerator and denominator, and then evaluate with direct substitution. So on your note sheet, we are going to look at 5 examples. In our first example, this one does not need L'Hopital's rule, but we are going to use it to model. This one could be done with factoring and then direct substitution. So the first thing that I will do is find the limit of the numerator separate from the denominator. So I know the limit as x approaches 2 of x squared minus 4 would be 2 squared minus 4, or 0. And in the denominator, the limit as x approaches 2 of x minus 2 would be 2 minus 2, or 0. Now I'm going to state that using L'Hopital's rule, and then I'm going to apply it. So I'm going to show that the limit of my original function, so x squared minus 4 over x minus 2, is equal to the limit as x approaches 2 of 2x over 1. And then I'll evaluate with direct substitution to get an answer of 4. Both a graph and a function in the denominator. So we'll again start by finding the limit of the numerator and denominator separately. So in the numerator, we are finding f of 3, which is our y value of 0. In the denominator, we're substituting 3 in directly. So we've shown that our limit is indeterminate. We will say using L'Hopital's rule, and then I will find the derivative of both the numerator and denominator. So the derivative of the numerator would be f prime of x. Derivative of denominator would be 2x. When we evaluate, f prime of 3 represents the slope of the tangent line at x equals 3. That would be negative 2. And then we sub into the denominator. And so our limit here is negative 1/3. We will again start by finding the limit of both numerator and denominator. So when I substitute 0 in for x, e to the 0 is 1, so the limit of the numerator is 0. In the denominator, when we substitute 0 in for x, we also have 0. So we will say, using L'Hopital's rule, so I'll state my original limit and set that equal to the limit of the derivative of numerator and denominator. So the derivative of the numerator is 2e to the 2x, so we have chain rule there. And as I evaluate with direct substitution, I would have 2e to the 2 times 0, or 2e to the 0. We know e to the 0 is 1, so our limit is 2. I want you to pause and try our last two examples, and then play the video to see the solutions. Last two examples, we'll start the same way, finding the limit of the numerator separate from the limit of the denominator. We see that with the table, it is 0 over 0. So I'll state that I'm using L'Hopital's rule, and then find the derivative. So the derivative of f of x minus 4 is f prime of x. In the denominator, we have to use product rule. So I would do derivative of first times the second plus first times derivative of second. And then I'm going to show that I'm substituting 2 in for x. Using the table, f prime of 2 is negative 2. G prime of 2 is 3. We sub in 2 for any x's that are there, and we knew that g of 2 was 0. So we end up with a limit of negative 1/6. Our last example is definitely a challenge. So we'll start by finding limit of numerator and denominator. We see that those are each 0. We state that we're using L'Hopital's rule. And when I find the derivative, I have f prime of x over 2x e to the x squared. So that one is a chain rule. But I notice right away that in the denominator, I'm going to get 0. And in the numerator, I will get 0. And that's because f prime of x, which is also dy dx, was defined as x over y. And we knew that when x was 0, y was 3. So f prime of x would be 0 over 3, which is 0. And then I see that my denominator is also 0. So I'm going to have to state again that the limit of the numerator is 0 and limit of denominator is 0. Even though I can see that by subbing it in mentally, I still need to list that out and state that I'm using L'Hopital's rule yet again. So now derivative of the numerator is f double prime of x. Dy dx was defined as x over y, so I need to do quotient rule here. And so that would be low d high minus high d low all over denominator squared. In the denominator, we've already taken the derivative there, so 2e to the x squared plus 4x squared e to the x squared. So that was product rule with chain rule. And then I evaluate by subbing 0 in for x, 3 in for y. Dy dx from what was given to us was 0 because we know dy dx is x over y. And so we end up with a limit of 1 over 6. Try the exit slip with your group once everyone has watched the video. I will post answers to that. That will be on our calendar. And then the homework worksheet is more straightforward problems with different functions that you can evaluate. Have a great day.